All right, so let's talk about how you get a K on the bottom. On the bottom. So, an example problem is the one that Mr. Rock asked about, which is dy dx equals negative 4x squared. Find y. Find the differential equation. Okay. So the first part's what we've been doing all along. So you get 1 over y by moving it to the other side. You get all the y's on one side, all the x's on the other side. Once you have that lined up, you integrate both sides. Bam, bam. Dx. Drop that off there. And I get ln y plus c equals negative 4/3 x to the third plus c. Now let's start playing with c's. This c is different than this c, so therefore c minus c is going to be just another c. We just don't bother changing the letter. Ln y, and then to get rid of the ln, I'm going to e to the negative 4/3 x squared plus c, and then to get rid of the opposite value bars, that y equals plus or minus e to the negative 4/3 x squared plus c. Perfectly reasonable answer, perfectly works. Clunky. And math clunky is bad. But it's the right answer. There's no doubt about it. You can actually say this is the right answer, and you would be correct. Well, where'd the k come from, and what is the k doing? Well, before I do that, let's explain briefly over here. Let's have a conversation about exponents. So specifically, if I have x to the third times x to the fourth, I have, remember, x times x times x times x times x times x, which gives me x to the seventh. So we quickly realize by doing this, realizing this is the first three and this is the second four. Remember what these numbers are. These two are going to add up and make whatever's up there, correct? So we learned a long time ago, x to the a times x to the b equals x to the a plus b. So let's look at this mess. The converse is true as well. X to the a plus b is equal to x to the a times x to the b. So let's look at this mess right here. Right here we have e to the negative 4/3 x to the third, that should be third by the way, plus c. All right? Well, couldn't I rewrite this if I wanted to? E to the negative 4/3 x to the third times e to the c. Well, what is e to the c? E to the c is just a number. Could be any number, right? So now it's traditional to switch this out to make this either a y naught or a k. I don't know why. Let's make it a k for right now, because that was the question asked. Negative 4/3 x to the third, right? In other words, this becomes one big fat k. And I just multiply it, put it out in front. Now, the advantage of that is, the first advantage of this is really, really, really obvious. When I get rid of the absolute value bars, is k positive or negative? I don't know. So why bother putting a plus or minus in there? I can get rid of my plus or minus, which is one of the things that's bothering me about this expression. The second advantage is more subtle, and is this. As long as this isn't something weird up here, when I plug in a 0, this whole thing becomes 0, right? 0 cubed times negative 4/3, that's all 0. E to the 0 is 1. So k is what y is when x is equal to 0. Or k is equal to the original condition of this problem, right? So at time equals 0, whatever, an x equals 0, my y value is this number right here, whatever that might be. And so it makes it really easy to solve for, really easy to deal with. Whereas if you have to go backwards and get this c out, it's your hair starts falling out from all the fun you're having, right? Because it's raised to a power, you're going to have to ln the whole thing. You have to worry about a plus or minus. You have to, like, this is much better, much, much, much better, right? All right, so that's how that happens. Hope that makes sense. If it doesn't, send me another post. Thank you.